So yeah, let us begin. And I will start with this question. As you can see it on the screen as well. I will ask you this to whoever is watching the stream. Why understanding the backend can make you a better dev, or I should say a UI dev, UX UI dev, because we are talking about UX UI in this presentation, right? So yeah, why should you know about the backend? Why should you know all the processes that are happening at the server side, all the data manipulation, how the database is being managed, how the data is being retrieved, or anything else like that? Why do you even care about it? And okay, first of all, this is not a YouTube live stream, so I cannot see anything which I could. But in this case, what I can do is right now is I can give you guys a few seconds, and what I wanted to do is right now is come up with some answers and keep those reasons in your mind, and then we will continue from that, right? So yeah, here are a few seconds. Hmm. So yeah, that is the time that you are gonna get because we don't have too much time for this presentation. I cannot take ages just for a single presentation. We need to continue, right? And I hope some of you came up with some reason, and I will start telling a few of those reasons that I can think of that I have came up with. Uh, Suppose we will just try to understand it by taking an example, right? Suppose we are working on an app. I am working on an app, and I'm part of a team. I'm part of UX UI team. So I need to know what is happening uh, at the back end because it is also the same app that I'm working on. So I need to know what the app is about, what the app is want to achieve, what the app wants the user to show, how the user want to use the app, what is user trying to get from the app, and all these factors. So that is why I need to collaborate with the other people in the team, right? Because our main goal is same to create that particular app for the end user. So I need to know that stuff because I need to know to collaborate with other people, to communicate with them, and to eventually build that app or that website or whatever else we are trying to build, right? So simply because we need to collaborate, we need to work together to make that app. And other reason that I can think are okay, let's just take another example to understand. Suppose I'm calling an API. Now I need to know what the API is doing, how much time it is taking, what data it is working on, if it is working on any data in the first place, and if it is taking, if I'm retrieving anything else, and if I need to show what I've retrieved on the screen to the end user. I need to all this stuff. I need to know all this stuff, right? So yeah, this is another reason because time duration is important for an app. If an app or an website is taking too much to load, the user is not gonna stay on that app. No one wants a slow running app. No one wants to use that app. No one wants to use even a laggy app. The user is gonna simply drop your app and just switch to any other alternative. And you don't want that. You want the user to keep using your app. So for that reason, you need to know stuff. So yeah, and we will continue. And here we have an interesting data from Google. And as you can see here, the probability of bounce increases 32%. Okay, first of all, for those of you who don't know what bounce is, let me try to explain it briefly. And what I would say is bounce is something what an user does when an app is taking too much. Here it is mentioned also from 1 second. 3 seconds. Wondering, okay, that is not a huge deal. 3 seconds is not a long duration of time, right? Well, actually, it is. Suppose if you are using an app which you use on a regular basis, and I'm assuming it works instantly. As soon as you click, it works. It loads the screen and everything happens. So suppose it is taking 5 seconds for each step that you are performing on that app, for each tap that you are making, or if it is a website, for each click that you are pressing on your mouse. Won't you get irritated? It is taking 5 seconds. Like if you are clicking 5 times, that is 25 seconds in total. That is almost half a minute. You spend half a minute in for just 5 clicks, which would have just happened in few seconds on a more efficient version of that website or that app. And you don't want that. And this data shows the same. So as a UI developer, it is your responsibility to make your app work as much fast. So the user don't go. It is your duty, it is your responsibility to make your app efficient to such extent that it works within a second. And continuing the question, why should UI devs care? I think I have mentioned these reasons before. To calibrate, you need to know what is happening around. You need to know the progress. You need to build an app in the end. So yeah, you need to know. Here is an example, speaking tree instead of nested menu. This is just an example. And it is vice versa. Like if you are aware of what is happening at the backend team must be aware of what is happening at the front end. And yeah, it is a two-way street. It it cannot happen with just one-way communication. You need to know, everyone needs to know everything. Feasibility, all the technical limits and all the efficiency stuff and all the time consumption stuff you need to know because you need to know the limit that this process is going to take this much time and etc etc etc. A laggy app, everyone abundance use a laggy app here is you can see 3 seconds. It will take 3 seconds for an user to judge your app to for them to judge if they want to use that app or not, and you want them to use your app or your website. Here is another interesting data from Google yet again. So what it is basically saying, an user want an app to remember their choices, their preferences. So the next time when they are returning to the app, they get to see the stuff related to their preferences and choices. And more than half of the user wanted. 56% of the users want that. And there are ways of doing it, which we are gonna discuss in this slide later. But yeah, you need to know that user prefer those kind of app who remembers your choice and who recommend things based on your past choices. For example, Spotify. Spotify recommends you new song based on your previous choices. So yeah. Now, okay, you don't need to get scared by these terms, trees and graph. I am not going to show you how to implement, how to search or how to apply DFS algorithm, BFF algorithm, how to invert a tree. No, this is not going to happen. This is just basic knowledge, and you will understand why I'm telling you this. Okay, just let me tell you this first of all. Okay, yeah. Arrays, like if your data is being stored in form of grids, like it is in on Pinterest or Instagram, like on the Explorer page of Instagram, there are these blocks. So yeah, these are just arrays of images or videos or anything other. And then trees. The example of trees here is you can see uh, Amazon shop by department. When you click on that book, you see categories of book: fantasy, thriller, romantic, drama. You see, and then you further click on that category, you see or further categories, subcategories, then name of the books. This is basically a tree. And then graph people you may know on LinkedIn, Facebook, Instagram, and yeah, this data is just shown on the screen. Yeah, it will make sense. Just wait, just be with me. Here is a representation of grid as I was talking about in the previous slide. Okay, and yeah, what else can you say from by looking at this slide? Yeah, I will give you another 5 seconds. Think about it and then I'll continue. Yeah, so by simply looking at it, you can see that these are two different screens, right? One has a different aspect ratio, another has a completely different aspect ratio. So yeah, your app should work fine, irrespective of the device, whether it is a laptop or a desktop PC, a mobile device, or a really huge screen. It should work just as it would work on any device uniformly in harmony. You don't want your performance to be dependent on a particular device. It should be respect. It shouldn't depend on a device, and it should work fine on every device. So yeah. Now these are some algorithm. We will talk about some algorithms now. And yeah, here you can see in this GIF the Google autocomplete. And there are few ways of doing it and calling the API to get the autocomplete list. Is you can call the API every time once after user presses a key on the keyboard. So for example, if a user is pressing G, then O, then O, then G, and then in this case you can call the API every time after each press. You can call it once G is pressed, you can call it after that when O is pressed, you can call it then again when O is pressed, then you can G. So you get my point, right? You can call API every time for each press button. But suppose if the user is typing a sentence and the sentence is like 20 or 30 characters, you cannot call the API 30 times, right? So there is another way of calling an API. You can call API in fixed time intervals. For example, uh, you can call an API as soon as the user stops typing. Yeah, that sounds right. Yeah. So how will you do that? You can maybe put a time delay. If user has stopped typing for 2 seconds, then pick that string and show me auto-completed result according to that string. And this is a much more efficient way to show the autocomplete list on the front end on the user interface, right? And the other example of algorithms are sorting. Sorting is not only in Airbnb, it is in, for example, a food delivery app. It can show you things from price low to high, popularity, a restaurant distance. How far is that restaurant so that you can get a rough idea if the restaurant is close by, so you will get your food early and all that stuff. Caching. You might have seen this. Okay, you must have seen this if you have used Netflix and services like Amazon Prime. Uh, it shows you the image of the movie where you left it, right? It will first show you suppose, for example, I was watching Harry Potter on Netflix. Then if for some reason, I just didn't watch the whole movie, I close the app and I launch the app again, and it will show me the thumbnail of that movie. And if I hover that mouse, and it will also show me the duration that I have watched it. So yeah, it depends. That's caching. That's example of caching for you. Now we will have a look what uh, great and what load time, how load time affects your conversion rate. This is data from Walmart, and this is basically conversion rate versus load time, and their conversion rate of customer versus the load time the websites were taking. As you can see here, the conversion rate is pretty high during for the duration of 0 to 1 second, and it drops more than 50% as soon as the duration increases just by a second. Now you see what a second can do to your app. It can cause that much effect. And you don't want that because in case of Walmart or any other e-commerce website, they are simply losing business. They are losing money, and you don't want that. And big corporate, or not just big corporate or big business, even if you are a newbie or just a beginner, uh, or someone else, you don't want that. You want user to keep using your app, right? So that's what even a second can do. So that is why loading time is necessary. That is why knowing stuff, what is happening, how data is being retrieved, how all the manipulation is going around. That is why it is necessary for you to know. And here is an example case study for Instagram user feed ranking algorithm. It ranks like, you can read about it in detail. You can just do a simple Google search. Yeah, but it's just a second. You will now again. I in the previous slide I just showed you an example of conversion rate dropping more than 50%. even in just a second. And what else can a second cause you, right? 11% fewer pages view. People will stop using, people will even stop viewing your page or stop using your app. 60% decrease in customer satisfaction. If it is an e-commerce app, if your user base is your customer, then yeah, they will be dissatisfied from your service. And 7% loss in conversion. If you are getting new users and it is taking just an extra second, even a single second, you will lose those extra customers, and it is not good for business. Now, let's talk about designing the structure. Okay, before I start talking about it, I would say mm, when you are making a full-fledged app and maybe in a huge company or somewhere else in an MNC, this is the job of a product designer, a product manager, I would say. But in this case, you will be in the GSOC, you will be making your own project, you will be designing your own product, you will be designing your own app, so you will be managing your own product. So yeah, you need to know this stuff. For example, user flow. Uh, if you want the login details, like like you might have seen some app which doesn't which don't even let the user see what is inside it, even if they don't log in first, if they don't put their email address, phone number, and all the other stuff. That's one of the user flow. And then there is partial visibility. The partial, some of the stuff is visible and the rest of stuff is not visible. So yeah, these are some user flows that you can keep in mind while designing your product or while making a app. Or okay, there is an example of e-commerce checkout queue. Um, Suppose you are buying a book from Amazon and there are only 10 books left in the stock. Okay, and you have put that book in your cart, and then come 9% they also buy the same book, and they have not just put their book in the cart, they have bought it, and now there is only one book remaining, and that is in your cart. So you will be in that queue, and the other user coming after you will start seeing that product out of stock. We can see another example like this here in India. We have an app, we have a service, ticketing service, railway ticketing service called IRCTC. So what IRCTC does is it lets you book railway ticket, train ticket. Suppose I am booking a ticket for myself from IRCTC. I enter my details, stuff, but I am not proceeding. I am not paying the amount. I am not doing the transaction. So what it will do is it will just log me out. My session will expire so that other people can take their seat. That's another example of queue. Okay, yeah. Now we have come to case study, Bloom filter. As you can see, like you might have got the idea what Bloom filter is by looking at this screenshot. This is Google sign up page. When Google asks you to create a new account, it looks something like this. It asks for your name and username to assign it to your Gmail, and it shows if the username is already taken or not. So you must be putting that information on the screen to let the user know if that email already exists or not. And let's just see how it works. How smart UI makes email registration lightning fast. So yeah, in this GIF you can clearly see what is happening here, right? And the user is typing its username and it is showing if the username is available or not. And let me just tell you briefly what it does. And I would highly recommend you to dive deeper into it because it is a really good thing, and yeah, you can implement in your app as well. So yeah, I would highly recommend you to just do a simple Google search Bloom filter. So what it actually does, like you might have heard of hash maps, right? It stores the data of all the users and all the existing. But Bloom filter is it not goes to every single username every time. It will because it will take too much time, and user don't. We have talked this countless time because we cannot take this much time. to let the user know if that username exists or not. So what Bloom filter does it is it works in two ways. It gives you two answers. For example, it Bloom filter will give you answer. We will try to understand it like this. Okay, so it will give you an answer like, okay, definitely not taken. This email is definitely not taken. So go ahead with it. Print on the screen. This username is fine. User can use it or whatever you want to print on the screen. Or another result it will give is maybe this is taken. Then what the algorithm will do is then it will search for the same username in the whole database. If that username exists, then it will show you the username already exists, and if it doesn't, then you are good to go. You can proceed with that username. So yeah, that was Bloom filter for you. Let's proceed to our next case study, which is Airbnb's case study. And here you can see some screenshot of mobile app of Airbnb. And I want you to observe one thing that the app is not clustered, right? There is so not so much information bombarding on my eyes like okay, there is limited amount of information on the screen and I can compile it, I can process in my brain at my own pace. So yeah, it is good. But earlier it was not like that. Like user was overwhelmed by 50 plus filters. Like there were huge filters on the app earlier on the or on the website. So they reduce the number of filters and the number of options. So the user doesn't get analysis paralysis because when you have too much choices, for example, you go to a restaurant and you are presented with the menu in front of you and you are looking like, oh wow, hundreds and thousands of choices. What should I eat? Oh my God. You will you will keep thinking and thinking and thinking and will end up taking some time and you are hungry in the first place and now you are like okay what I am hungry what should I you are getting right, you are getting my point because you have got so many choices. It is basically paradox of choices. Yeah, paradox of choices, I would say. The more choices you get, the more difficult it becomes for you to process all the information and to come to a conclusion. And that was happening earlier in the app and they removed it. So what did they do? Combined caching like preload common searches because people are already searching and priority queues that we have talked about earlier. And you can also see the result in 20% increase in booking. So yeah, this was Airbnb's case study. And now some challenges and practices. Avoid overcomplication. Like we just talked about in the previous example. The 50 plus filter and all the menu example, restaurant example. Use grid for items is just an example of in a certain way in your app. You can, like we also talked about putting data in a tree form in hierarchy format in Amazon. So yeah, don't overcomplicate stuff. User will get confused from so many choices and it will it will harm your customer base because as you see in the previous slide the custom booking rate increases 20%, right? Earlier if it is increasing 20%, then if it was not earlier then you were losing on some customers or some users, right? So yeah, don't overcomplicate stuff. Second is user centric data. Another example is showed by most popular. What people are seeing around you, just show the new user data as well, because chances are they also want to see the same thing on the app. AI personalization, Spotify Discover Weekly, or YouTube recommendation page, they all work on these principle. Keep auditing your data ethics. These are some practice and challenges that you can keep in mind while designing or making your app so that users keep using your app. So yeah, that was it from my side. I hope you like the presentation. Keep lodging in mind, keep designing your app, uh, keep bridging the gap. And if you have any questions, you can ask me in the Discord server or in the video of this comment, in the comment of this video, sorry. Or yeah, I'll answer your questions in the Discord server. And I hope it was great. Thank you so much.